In our second lesson of this unit, we are going to be looking at parallel lines. Our learning goals are to identify angles, unknown angles, using the three parallel line theorems. In these problems, we will be given a set of parallel lines. So to start off with, these two lines here are parallel. I know that because they are both indicated with an arrow, meaning that they are parallel to each other. We see that they have another line that cuts through the two parallel lines. This is called a transversal line. When a transversal line intersects through two parallel lines, there are a number of angles which are formed that have a relationship, and we are going to look at the different relationships below. The first relationship happens when we have alternate angles. Alternate angles are when we have angles that lie on the inside of the parallel lines, so in between the two parallel lines, and they are on opposite side of the transversal, so C and F or D and E. These form a Z pattern, which is where we get PLTZ, parallel line theorem Z. So what I can do to show this is highlight this pattern on this set of lines I have. So what I do is I trap one angle and I can trap the other angle. When I say trap, I mean that I'm coloring the two lines that trap the angle, that are connected to that angle. So I've drawn that around angle F and I've drawn it around angle C, and I see that I form a Z pattern or a Z shape. And when I see that Z shape, that means that the angles that are trapped by the Z, so angle C and angle F, are equal to each other. So I'm going to say C equals F here. Below, I have another set of parallel lines, and this is because I have another Z pattern formed that I can form. This time I'm going to trap angle D and I'm going to trap angle E. So this is a backward Z, and if you notice that angle D is trapped by the two lines that I colored, and same with angle E, and that means that angle D and angle E are equal to each other. Again, you can notice that all the angles we discussed are on the inside of our two parallel lines, and in each diagram they're on opposite side of the transversal. The second relationship is formed when we have corresponding angles. Corresponding angles are always equal, and we can find corresponding angles when we see an F pattern. So here, I can form four different types of Fs given two parallel lines and a transversal. My first F, I will trap angle D, and I'm going to trap angle H. Do you see how the leg of the transversal continues past the parallel line? When we had a Z, it stopped at the parallel line when I was coloring the transversal. Here the transversal is colored in between the two parallel lines and past the parallel line. And then I'm coloring the two arms. So the two angles I'm talking about are angle D and angle H, because both of those are trapped by this F that I have formed. And we say that the two angles are equal to each other. Angle D is equal to angle H. So I'll actually write that here. Another F pattern I can form is the same transversal. It goes past the bottom parallel line. It should not go past the top one. And I'm just going to draw a backwards F. So I just go down each parallel line. So I have two arms of my F, and I trap angle C, and I've trapped angle G. So that means those two angles are equal to each other. I can also have upside down Fs. So this will happen when the leg of your F goes on the other side of your parallel lines, and it stops here. And I will put the arms to the right. So you can see I've trapped angle B and angle F. So I can say B and F are equal. And then the last one is also an upside down F, but it's also a backwards F. So I've trapped angle A and I have trapped angle E. So that means those two angles are equal to each other. So those are the 4 different types of Fs that can be drawn. It's a good idea if you have an upside down F to actually turn your page around so it can be a right side F. Might be a little bit easier to identify the F pattern. And my final relationship happens when I form a C pattern and I get interior angles. Interior angles are in between the 2 parallel lines, but they lie on the same side of the transversal, and it will form a C. So here I'm going to trap my angle D, and I'm going to trap my angle F. If you notice, they're both on the right side of my transversal, and they're both on the inside of my parallel lines. Now you can see F is acute and D is obtuse, so they are not equal, but they do have a relationship, and where they are equal, when you add them together, they equal 180 degrees. The other C I can draw is a backwards C. So I'm going to trap angle E and trap angle C. And again, C and E are on the inside of my parallel lines and they're on the left side. So now I can see E is obtuse, C is acute. And we can say that C plus E equals 180 degrees. So those are the 3 parallel line theorems, which we're now going to practice on the next page. On this page, we are practicing highlighting the different Z patterns, F patterns, and C patterns. So we're not actually going to answer anything, we're just going to identify these patterns. In question 1, it says PLTZ. So I can't do it on the computer here, but what you can do is turn this page around so your 2 parallel lines are horizontal. So they look like this. And you should get 2 Z patterns, and I will try to do it in different colors. That Z pattern and that Z pattern. They're pink and the blue Z pattern. So I go along the transversal and I go on either side of the transversal, one on one parallel line, the other way on the other parallel line, and opposite for the pink. For question 2, it's my first Z and my second Z. Question 3, again, it will be easier if you turn your page, but that's what your Zs would look like. Question 4, you might want to turn your page again, but those are your Zs. And question 5, again, probably easier if you turn your page, but those are your 2 Z patterns. In question 2, we want the F patterns. Now there should be 4, but it might get a little hard to show all 4 on each diagram, so I will just do 2 on each. Again, 1, I would flip your page around so the 2 parallel lines are horizontal. And remember for F, this is where one arm goes past the parallel line and you go along the same way down both parallel lines. And then my other F pattern could be just facing the other way. In question 2, I'm going to do an upside down F. So the arm of my F is going to go up above my parallel line, and I can go to the left. And then another F, you can see I've done this one where it goes past my parallel line at the bottom and then to the right. Yours might be a little bit different because there's 4 possibilities. I'm going to stop here and move on to question 3, where we want to find the C patterns. There should be only 2 in each question. C pattern, you go along the transversal, you don't go past the 2 parallel lines, and you go the same direction. So in this case, I'm going up, or if you've turned your page around, you're going to the right. And my second C is backwards C. And then that's my other possibilities for question 2. On this page, we are going to do 6 examples where not only we color in our different shapes, we are also going to actually start solving for angles. So these angles are, unknown angles are identified by these question marks. Usually they will be identified using small letters. So if you look at this, we're given this angle of 110 and another angle of 70. Those angles are on the outside of my parallel lines, which means I'm going to use an F pattern. I have to use an upside down F because my angles given are on the outside at the top. And I'm going to draw my F to the right. So I know that this question mark is the same thing as 70. So I'm going to say 70 degrees here, and I'm going to write that I use the parallel line theorem F. Now to find this angle here, there's 2 ways of doing it. I could do another F pattern. So this would be 110 degrees, again because of PLTF. Or you could have said that because this is 70, this is 110 because I know they both add to 180. And so I would have said that this question mark is equal to 110 because of SAT, supplementary angle theorem, instead of PLTF. So the more angles you have and the more you start to find, the more reasons that you could use to solve for the rest of the unknown angles. In question 2, again, I have these angles at the top. So I will be using an upside down F. So this question mark is equal to 95 degrees because of PLTZ. And then I could use this upside down backwards F. So this question mark is 85 degrees, again, because of PLTZ. You could have solved this first question mark by using supplementary angle theorem SAT because you have 2 angles on a straight line, add to 180. And you could have done the same up here. But we're practicing the parallel line theorems, which is why I used the F pattern to solve it. In question 3, I now have 2 angles at the bottom, one known, one unknown. But because they're on the outside of my parallel lines, again, I'm going to use F. So this question mark is 60 because of PLTF. And then I can do a backwards F. And to find this question mark is 120 degrees because of PLTF. In question 4, I don't have either of my angles on the outside of my parallel lines. They're all on the inside. I have this known is 50 degrees. This angle is known as 130. That makes sense because they need to add to 180. So my 2 possibilities are Z pattern and C pattern. Let's first try the Z. The Z works. I have 50, which is trapped with a Z, and I have this question mark, which is trapped with a Z. So that question mark is the same thing as the 50, and I use PLTZ. The other angle, I can do a backward Z, and I know that this question mark is equal to 130 because both of those angles are trapped when I drew that Z. So this question mark is 130 because of PLTZ. You could have also solved this question mark by using PLTC, knowing that the 2 angles are equal to 180. So that could have worked as well. But we're going to practice the C pattern in number 5 and 6. In number 5, I have this one angle given. I have one unknown. So when I trap both of them, I get a C pattern. They're both on the same side of the transversal, and they're both on the inside of the two parallel lines. These two are not equal. They add up to 180. So the question mark is 180, take away 50, which is 130 degrees. And that's because of PLT C. And question 6, I use a backward C. Again, both angles, the one I have and the one I need to find, are on the same side of the transversal line, and they're both on the interior of my two parallel lines. So to find this, it's 180 take away 44, which is 136, and your reason is PLTC. So those are some examples on how to use the parallel line theorems. There is another 2 pages of parallel line theorems that you can try and practice your skills.